A second problem on projectile motion. We have a tower or a table, something of height h, and an object that is thrown horizontally off the edge of this tower / table with the speed v0. And we are asked, what is the time until the object hits the ground? What is the speed of the object as it hits the ground? And what is the angle made by the velocity with the horizontal? So once again, we have a tower or a table of height h, and there is an object that is launched horizontally from this height, and as it travels, the object will hit the ground, and we are asked to find the time it takes the object to fall, the speed at this point, and the angle that the velocity makes with the horizontal. We decompose this motion into two motions, one along x and one along y. Along x, our equation that relates position with time can be rewritten as d being the final position, 0 is the initial position along x, plus v naught t plus 1/2 times 0 times t squared. There is no acceleration along the x-axis. So d is equal to v naught t. Is one important equation. Since we are along x, there is a second equation that we can use. Vf is equal to vi plus at, which in this case becomes v final along x, is equal to v initial along x, which is precisely v0, plus 0 multiplied by t, because again there is no acceleration along the x direction. So vfx is equal, in fact, to the initial velocity v0. Along y, the final position of the object is 0. The initial position of the object is h. The initial velocity along y is 0 because the velocity is horizontal, so it does not have a y component. And the acceleration, as always, is negative g. So this equation becomes 0 is equal to h minus 1/2 gt squared. And finally, the final velocity along y is equal to the initial velocity along y, which is 0, minus gt. We are using this equation again. This is the initial velocity. Acceleration is negative g. So the final velocity along y is negative gt. Now, depending on what we know and what we don't know, these equations will always be sufficient. So in this case, if we want to find the time, it looks like we should go back to equation 3. So from equation 3, 0 is h minus 1/2 gt squared, or t is square root of 2h over g. In order to find the final speed, if we have the components, it is easy to find the final speed using the Pythagorean theorem. So Vfx is V0 and is clearly positive, while VFY is negative GT is clearly negative, which means it will point down. When we add these two vectors, we have V is square root of VFX squared plus VFY squared, or equal to square root of V0 squared plus G squared T squared, in which I use the fact that VFY is equal to negative GT. But of course we know T, so this will become V0 squared plus G squared, and instead of T squared I'm writing 2H over G. T square root of 2H over G, so T squared is simply 2H over G. So V will be V0 squared plus 2GH. And if we want to find the angle alpha that the velocity vector makes with the horizontal, we go back here and we are saying tangent of alpha is VFY over VFX, the opposite over the adjacent. The opposite is GT, and the adjacent is V0, or G over V0 square root of 2H over G. So alpha will be inverse tangent of 1 over V0 square root of 2GH.